real time? Because until unless we go in the life in the situation that the system has to work, it will be very difficult for anybody to analyze, right? We have good simulation tools. We normally simulate the things first, but after the simulation, the important part is how the system would behave in the real-time environment. And this is why we are talking about the information and why this is so important, right? So once you get the information, you might be the king of the world today, right? If you're having this kind of an information, you are the topper. You are having everything with yourself, right? You do not need anything else. People will come to you to take the information in that case. So what are the enabling technologies? Now have a look. If you see, you see certain processor chips over here, right? So I'll just highlight them over here. These are some of the processor chips and how this behaves. Have a look over what I'm trying to do. Microcontroller performing these kinds of actions. I hope everybody understands this. We are having a controller in a car system, a microwave, a gaming structure, or some measurement home automation systems, right? Then we have flash storage. I don't know, it is not coming up that good flash storage, but you can still imagine the flash storage. You've seen this pen drive structure, right? These are also flash memories. These are all flash memories over here, right? The third part is the radio communication. The radio communication is what we are right now using, the mobile phones, the gaming consoles, right? So if you see, everything is basically related with the transistor structures or transistor boom that we had, and we are talking about IEEE 802.15.4 protocol being utilized in this case, right? So if you see, there are different devices in this scenario. We have some measurement devices, we have some other instruments in which they can be utilized, the information can be utilized. These are the transistors, the capacitance, or the semiconductor devices, as I can call them, in a simple thing. Now have a look. We combine these three together. So once you combine them together, we try and formulate a network of all the three. And when you form the network, we say we are trying to formulate a technology which is enabling all the aspects together. I'll again just do the reverse process here. I'll just discard this and then show you the slide again. Kindly have a look over this, right? So microcontrollers, the flash storage, the radio communications, and the protocol, right? We have all defined. Now we are having the sensors over here. The sensors are, they can be any sensors, humidity, temperature, whatever you want to measure, the torque, etc., etc. So I want to combine them together. Now, how do I combine them together? Right? Using this semiconductor technology, all the sensors are built, right? And now how do I build the enabling technology? So I am enabling these technologies, right? And I formulate this complete network structure based on what knowledge I had gained over past several thousand, I should not call thousands, but I can call them as 100 years right now, right? Because in less than 100 years, we have been advancing to such an extent that I think day is not that far that you just think and the things would happen. Right now we are moving into that particular scenario. You are thinking and things would start happening for you, right? So this is the protocol. It is written way beyond the slide, but yes, you can definitely identify it. IEEE 802.15.4, right? So this particular protocol is being utilized. All those who are from computer science engineering might just understand use the ZigBee IEEE structure, right? So ZigBee protocol for low rate wireless personal area networks, as we call them, right? So internet concepts, what they are layering. If you see, we all know about this layering: physical layer, the link layer, the network layer, the application layer, the transport layer, right? So you know all about the layering part and how this layering is utilized. So I'm not going into that detail, I'm just trying to tell you how systems would behave, right? So when we are talking about some application part, we are referring to these kind of protocols. When we are talking about the diverse object and data models, we are referring to this protocol. Transport layer is utilizing the TCP/IP and the UDP. We are talking about network or IP structures. We are still using them, right? The network link structure, where we are talking about the Ethernet, the token ring, the Wi-Fi, all the protocols here, and then GPRS, right? How do they fit in? Have a look. GPRS, DSL, ISDN, SONET 802.33 is talking about 1 GB BT speed, right? 802.3 AN Ethernet, 802.11n with Wi-Fi. What beyond this? 802.15.4. What beyond this, right? We will try and answer this. So leading internet research perspective, that was just a decade ago, right? So you can understand it is not that old for us, but still, we once we understand this, we'll understand why we are talking about all these things together. So resource constraints may cause us to give up the layered architecture. Definitely, we cannot rely heavily on this layered architecture because it has some limiting functions. So what limiting functions it has, I hope everybody understands that. And then the number of devices, how they are increasing, how the structure is increasing. So what needs to be done? So sheer number of devices that there are unattended and they are not deployed right now, but they have the utility, will preclude the reliance on broadcast communication or the configuration, right, currently needed to deploy or operate these network devices. As I just showed you, the networking between the devices, and hence the significant robustness and scalability, or the advantages to designing applications using localized algorithms would also feature in those things. And unlike traditional networks, what a sensor node may not need an identity. Very important, very important. Right now, we cannot think any application where we do not work with an identity, right? So this is an important thing. We are talking about the traditional networks which are based on the identity part, and sensor nodes which do not need identity, or example any addresses, right? So if they are not having addresses, how will they communicate? So this is what the protocol structure is all about. So we will have to develop certain things, and it is reasonable to assume what, that sensor networks can be tailored to the application at the end, right? So we were thinking about this, and all what we found in the research was that we were totally wrong, right? We were thinking on some different scenarios, and we were limiting our things, right? So internet research just stopped at IPv4 or IPv6, but still, this is just the beginning in that case, right? So what can be shown and what can be done using this particular scenario is entirely very different in the sense that we haven't imagined all what we will be able to do while we are talking about these perspectives, right? So have a look, the Morte or Tiny OS revolution, right? Have a look over this. I hope you have seen certain things in this slide. It took me a while to actually inculcate all these things, but have a look over what has been mentioned in this, right? So if you see, we have a smart dust sensor over here, a Reni sensor, Intel Reni or Intel USB dot. We have a mica over here, again Intel CF mica being utilized, Intel iMode being utilized. All these are developed by them. Then we have Nokia here, we have HP, we have Octave, we have Trio, right? So if you see, what we are having is, we are having these numbers over here: 8 KB ROM, half KB, sorry, 8 KB ROM and half KB RAM. Then the utilization of NSF, Sense, STC, right? So if you see, we are referring to the cyber physical structure, right, being developed by all these companies. Now, if you see again, I referred to this low pan. Low pan means what we are talking about is, I just gave the name low pan. If anybody can just repeat it for me, I would think that we are actually still vacant enough. So it is what it is. It is low power wireless personal area networks. See, right? So we are talking about low power personal area networks, or in fact wireless personal area networks, and which is utilizing this IPv6 right now, currently IPv6. So we are reducing the size, we are reducing the structures, we are reducing the protocols to be utilized, and we are making individual systems, right? So this particular thing evolved into a concept of internet of everything, which was realized in 2008. I don't know how many of we were aware at this point that even internet of everything was there. We were not even aware about IoT. I was at least not aware of this term called as IoT, right? Internet of things. But right now, we in 2008 this concept had already come into picture, where they were referring to internet of everything, right? So internet of everything means we are trying to combine, as I showed you, we are trying to combine all the things together and utilizing the network layer features effectively. So in some cases you will see these network layer features will also be they will just fade away, and we will think beyond this protocol also, this 802.15.4, right? This encryption basically utilizes a lot of ROM and the RAM part, but after this we'll be able to move ahead out of this, right? We had started from TCP and UDP, if you remember. So have a look over the things that are going on, right? So footprint, power packet size, bandwidth, entire data I have placed over here to ensure that everybody understands that internet of everything, what it is talking about. So the standard internet of everything was given by the Zigbee Alliance and the IPSO Alliance, that is enabling the internet of things, which was enabling that in the years 2010. And this is some of the data which is available. So Zigbee Smart Energy version 2.0 was launched, and IP-based offer of variety of new features were actually introduced. So what is networking in a physical world? We need to understand this, and how once we understand what is networking, then we'll be able to understand why protocols are very important for us, why protocols are required, right? So have a look. Application requirements. If you see these pictures, we all are different genres, right? If you see, all are different things. Application requirements. So what are the application requirements? It is embedding in physical space. It is large number of nodes, low total cost of ownership, right? Then network challenges. What are the challenges? Challenges are some variable communication, some constrained resources, and some low power wireless. Very important. Again, this low PAN would come into picture. Low power wireless, right? So we are talking about multi-hop, we are talking about low SNR, we are talking about small MTU, right? So let's see how these network challenges can be overcome, right? We are already facing these challenges of buffering. You must have seen right now also, because I'm using a particular network and a particular protocol structure. I don't know when the network would go down and my system would still start this arrow moving around and showing me that the data is still buffering around, right? So we are already facing this kind of an issue while we are attending the classes also. So how do we talk about, or how do we overcome these network challenges in the physical world? We need to see that, and confluence of research, industry, and standards. This talks about how we can just combine them together. This is the first diagram, if you remember, I had showed you. This is all the entire network, and we were trying to combine them together, right? So combining them together, utilizing the features of the available research that has been done, the standards have been utilized, and how they will be used, right? So key research developments that happened, that is event-driven component-based operating system, right? We have been talking about that, and we have been using them also. Like what we have is, we have framework for building system or network abstractions. We have low power protocols. We have hardware and application specific things. Ideal listening is also there, where all the energy is consumed by listening for a packet to receive, and we need to turn radio only when there is something to hear. We will not keep on switching it. We will not keep it on for the entire uh, particular value, right, or for some time. So it is only on when there is something to hear. So reliable routing on low power and lossy links. What is reliable routing? Power range obstructions is greater than equal to the multi-hop. Always at edge of SNR, that is also greater than equal to loss in common, and we have monitoring, retransmission, and local rerouting, right? So these are key research developments that have been done in the area of reliable routing. Trickle or don't flood, right? So trickle means we are sending the information at in such a fashion that the person who is trying to receive it actually gets it, and the information is not lost. So connectivity is determined by physical point of interest and not the designer, right? Nearly naively respond to a broadcast, right, and rebroadcast very politely if you have to do it. Otherwise, broadcasting will actually solve your problem. So what comes out of all this is the tiny OS, or the framework for innovation, right? So this tiny OS, I hope everybody has heard this term, but still, those who haven't heard what tiny OS actually means, it is again related with an embedded component-based operating system, right? So we are talking about component-based operating system and platform for low power or wireless devices, right? So it is basically a WSN Mate platform. So have a look over what happens. So again, the application layer or application services are there. So over the air programming, very new thing right now for us, but it is being utilized for a longer period than what we had been hearing, right? So over the air programming is very interesting newer aspect as far as the research goes. We have some network protocols, link, radio serial, block logs, flash, right? So if you see wireless storage, processing, and sensors, right? So I've tried to categorize all these together, and if you see what would happen now, sensors, the data, streaming drivers or ADC sensors sending this information for scheduling or management, right? MCU timers are actually making sure that the microcontroller unit is receiving it in a particular time and then processing it. Then after this, what happens, right? Have a look. Once this scheduling and management is done, it is then forwarded to what? The storage part, the blocks, the logs or files, right? And lastly, it can be also transmitted directly to the wireless system. So there are two things: either you store it or you transfer the entire information that has been managed or scheduled or worked on or processed on, I should say, by the processors. Either you can store them. So I've just shown you how the things can be stored over here in the form of logs and flash, or they can be transmitted directly through radio devices or through network protocols or through wireless sensor networks, as we call them. And tiny OS is the one which is actually utilizing them, right? So I'll just again show you this. I hope my voice is coming pretty much clear.
Yes, sir.
Okay. If you see again, have a look over this. This is an important aspect of the framework for innovation that has been designed. Data once sensed has been streamed to the controller part, right? Through the application services. The MCU part is scheduling them, managing them, processing them, and then either it can store the information, so you'll just see the data buffer being full, right? And after this, what we can do is, yes, it is full now. And the next part is either it can be stored or it can be directly retransmitted or transmitted through some radio part. It can be any wireless radio structure to the source or the receiver, right? So this is the tiny OS structure. So this is how it works. So the arrow would move just out. I hope you are able to utilize this. Now this is how things can be monitored easily, right? You can see the communication happening. So over the air transmission or over the air programming might also help in. From the storage also, the data can be wirelessly sent or the data can be wirelessly transferred to through the microcontroller unit directly, right? So this is called as communication centric resource constrained event driven execution. Now this is the complete name, right? And I hope you are able to see and understand what I am trying to depict through this particular slide, right? So a worldwide community which is talking about some wireless sensor networks. If you can have a look, just go back. BWRC, TinyOS, Smart Dust. I think you heard almost all the names, the Atmel, the Intels, Honeywell, right? And then the wireless sensor network comes into picture, and then see how many brands have turned up and how and what is the country and region in which the things are being utilized. So tiny operating systems are well into their boom, and USA or say even Korea, Republic of Korea is utilizing it to the fullest. And if I say India, yes, India is pretty much into picture. The United Kingdom, the China is also, but not to that extent. But yes, it is utilizing the features here. Normally, if you see USA and Republic of Korea, also the Indian subcontinent is basically into utilizing these tiny OS structures, and Intel is one of the leaders, right? Intel has already uh, led into all these tiny operating systems, and then followed by some dust networks or Crossbow is another one, since HP has also taken into this thing. Nokia is just coming up with the low power networking systems, right? So what low power networking in real world is, kindly have a look over this. Again, that same diagram, if you see the wireless, the storage, processing, and sensors. Again, we will always take this into consideration. This is our base, and let's see what happens when the things are actually sensed once the things are transmitted. So how they are done: architecture, system, network, and application, right? So application returns it back also. So this is the technology, and these are the areas. This is the application part, right? So we are transmitting the information to them and also receiving back what they want to convey, and then retransmitting it after the reception has been done. So a low power standard link basically talks about again the IEEE standards of 802.15, also 11 also there. So if you see, we have the class of WPAN, 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 right? And initially, in very beginning, we had LAN and WLAN, right? So we are not right now. Also, we are talking about these in our country, right? We are talking about these two, but the next part is definitely going to be 802.15.4, where we talk about low power, large scale, and low cost devices, right? So their lifetime is also pretty high. The network size is also very high. The bandwidth in kbps, you can just have a look, right? The bandwidth is almost negligible as compared to this LAN part, right? But it is very fast, right? Range, okay, and then definitely we are talking about some low power consumption. We are talking about some large scale structures. We are talking about low cost, right? So there is no cable required in this, and we will be moving around and then getting this data very interestingly at this speed. Again, we will be very happy to do it. We are already doing it. We are already doing it with the help of our mobile phones, right? So decade of networking, what it has done, it has caused the changes, as you can see, from 1999 to 2008 and onwards, right? So link, network, transport, and application, and different protocols have been developed. Different things have come up which are being utilized by some machines that we are normally using. So the ideal listening problem, what is that? Basically it is the power consumption of short range, right, or low power, short range or low power wireless communication, and is roughly the same when we are trying to transmit or receive, or while we are just keeping our system simply on, or for listening for the potential reception, right? In that case, we have 802.1.5.4 Z-Wave, Bluetooth, and Wi-Fi, right? All these things are being utilized these days. The ideal listening problem is again categorized with this particular point, that radio must be on in order to receive anything. So transmission, if it is rare, and listening happens all the time. This is another time which we normally do it. We keep our mobile phones on daily. Do you get a call daily? Means do you get a call each second or each minute? No, we don't. Always on. So what we are doing is we are trying to listen to an ideal channel. Once in some time somebody would call us, we will have the information, or we might not even like to pick that particular thing. We may cut that particular aspect, right? So we are performing this kind of an action almost every time. Ideal listening, right? So we are listening to the channels. Either it is Bluetooth, Wi-Fi, Z-Wave, or any other channel that we have got, any other protocol that we have. We are listening to them, and we are waiting for the information to arrive, right? So this is the problem. This is a problem. We are wasting the energy, right? I just gave you an example. You don't get the call each minute or each day, each second. So still your mobile phone is active, and you are losing the battery. I hope you all agree. Sir, I hope my voice is coming because I just had some interruption. Is my voice audible?
Yes, sir.
Right, sir. Right, sir. Thank you very much. I just had an interruption, so I thought I'll just ask you out. So now, if you see communication power or passive vigilance, this is how. I'll just show you this. Listen just when there is something to hear. Right? You're sleeping at the point, transmit. So across comes, then transmit, across comes, then receiving at this point, right? So if you see, this particular chart is telling us the communication power of passive vigilance, right? Listen just when there is something to hear. So we are saving power in that case. Now, how our systems would behave, or how our systems would, I will just have a look in this list here, right? So three basic solutions that have been given and that are being used, but still I'm trying to highlight them for you, right? Scheduled listening. This is one of the common things that we have, and in very beginning we were using them, like we were using it for Aloha, Token Ring, right, TDMA, and we had the Bluetooth or Piconets also coming into picture. Scheduled listening. What we do is we arrange a schedule of communication time slots, and in those time slots only we wait for the information to come, right? So maintain the coordinated clocks and schedule that is done by the machine. The next part is sampled listening. So listen for a very short interval, right? Sample means a very short interval. On detection, listen actively to receive. What we are talking about is, again, this was used earlier. DARPA. DARPA. I don't know how many of you know this name, DARPA packet radio, right? So this was one of the most effective and common thing that we were referring to, the DARPA net. We net. right? So this particular thing was pretty old. ARPANET, DARPANET. I hope everybody remembers them. These are one of the first initial networks that were being utilized, right? So maintain always on illusion, but they are robust in nature. Listen after send with powered infrastructure, and many hybrids are also possible. Many hybrids are there which are actually utilizing it to save power in all the machines. So for your mobile phones also, the same thing is being utilized. 802.15.3e is the solution. Now, if you see routing in low power wireless networks, I'll just try and show you this rather than talking much. I'll try and show you how this routing is done. So you can see the routers, you can see the clouds, the networks. Right now, this is the PAN or the personal area network that we have developed. The classic view is that network is established, and now how the information can be transmitted from this side to this side. We will have the routing algorithms to find the best path, right? So hop by hop table addressing is done, and this is how it will be done. Now have a look. So what we'll do is we'll just change. We will have a to see how the self-organized routing is utilized. Now you can see there are so many routers placed here. Have a look. And I've given this particular point as zero. No, this point as zero, right? So just have a look. So information is a network has been established. One. Another network will be established now. So two to this network. Then a third network is established, a fourth one, a fifth one, and a sixth one. It's like this, right? So entire routers are now connected, right? So what we want is now this is self-organized routing nutshell. Again, I repeat, if you are not following this, this is an important technique that is being utilized. I'll just show you again. Have a look over what has been done. This was the first one. This was right 0 to 1 and 1. The second one, the network was formulated, and now it will go on self-organizing itself once the third input is given. Right, have a look over this. Right, so it is self-organizing the routing, has connected everything, and now what would happen? See, the packet has to be sent from that particular point to 0. So how it will go? Have a look. There's a reached, right? So it is just self-organizing. Easily it can be explained, right? Receiver diversity through a dynamic uh, rerouting restrains this density of this particular table in the RAM part, and this is again I'll just show you how this packet was moving around, right? You can see the packet routing, the self-organized routing in different for different packets, right? For even all the protocols may be utilized. So IPv6 is the latest contribution that we will be seeing shortly. Very shortly, we'll be utilizing those things only, and we'll forget about IPv4. I hope everybody knows what this IPv4 and IPv6 are. So the contributions are very because we are increasing the size to 128 bits in IPv6, right? So large and simple addressing, the network ID plus the interface ID is given in this case. Auto configuration and management utilized in this. We have an integrated bootstrap and discovery. So all these protocols, we are talking about protocol locations and protocol options, right? So we have a protocol option framework also, actually meant for the user who is using it. Plan for extensibility. We have a simplified version for speed of MTUs, and we have 6 to 4 translation for compatibility. So this is how it looks like. If you can see this area, we'll just mark it out for you. Now this is how the structure looks like, right?
Hello, sir.
Hello?
Hello.
Hello?
Yes, sir. It's
Yes,
audible,
sir.
sir. Yeah.
Yeah, my voice is coming, sir.
Yes, sir. Now it's audible, sir. Yeah. Yes, sir.
Okay. So the short range embedded and the minimum transfer units, that is fragmentation on multiple hops. How will we go with them?
Sir, screen
Because
is
we
not
have
visible, sir. Screen.
screen is not visible.
Yes, sir.
I'll,
Yes,
I'll
sir.
just I'll just share it again, sir.
Yes, sir.
Right. Is it visible now, sir?
No. Yes, sir. Yes, sir. Now it's visible, sir. Thank you. Yes, sir.
Okay. So again, if you see, we have a 6-low WPAN IPv6 over. We are trying to send it over 802.15.4, and this is how it will work over, right? 6-low WPAN adaptation layer, right? So we have low power wireless personal area network using the 802.15.4, and these are all the protocol structures that we have. Well, now I'm not going into detail, but just trying to show you that these are normally existent, and we are actually utilizing the network backend and link frame structures in while we are transferring the IP using the IPv6, right? So additional IPv6 options are also there, right? IP routing everywhere, wherever you see some internet being used, you are using the IP routing, right? And the IP routing basically is utilizing the conventional IP link. You can connect to any of the Wi-Fi's available around you. The only thing that you require once you connect is the password, right? If it is password protected. Other than that, the network is intelligent enough to identify which protocol you are looking forward for and what protocol is the best during that particular access, right? So normally 802.11 is the one that you normally used, and switched Ethernet is 802.11s. So 15.4, etc. are utilized only when you start using the other services, right? Or the low power services such as the Bluetooth, etc. So structured decomposition, IP link, always on, IP link, reliable, IP link, broadcast domain. These are the three things that we can use. So IP link always on means retain illusion even when always off, right? So this is the illusion. IP link reliable means retain best effort reliability over unreliable links, and IP link broadcast domain, basically IPv6 can support a semi-broadcast rather than a broadcast domain link, right? So there are few changes in that, and IPv6 needs to be modified for the broadcasting purpose, right? So example of auto configuration, basically we have many things. If you can see, this particular diagram talks about IPv6 header, the router address, the prefix info, and the mHop info, right? So everything is there, and the state address auto configuration is signified by the RF762. The neighbor discovery is done by IHCP, right? So again, what I'm trying to talk about this is these are some of the examples where routing is utilized with IPv6 right now. These IPv6 can be a pretty interesting thing for all of us, right? We are some IPv4, the addressing, right? So building a connectivity graph, then selecting the next hop might be something that can be done easily with IPv6, and this is how the stack would look like, right? This is the stack. We have a link layer, network layer, transport layer, application layer, the 4-layer structures, and then how everything for IPv6 fits inside it. I'll just try to depict this through this diagram, right? And once we add it, here I had shown you this earlier also, this 6-low VPAN IPv6. So if you see, this is the data available, right? So why this is important? Because we are talking about some low power devices and low power consumption. So we always need to look into the table while we are referring to the power and the reliability. And this is how it looks like, right? So data sensitivity, data rate using the router, and data rate sensitivity using the edge. So these are two things. So deployment of these two depend on their power and reliable options that are available or that the service provider provides, right? So what has changed with the role? The requirement case studies, that is the building RFCs, narrow the domain, establish constraints, right? IETF for the routing protocol survey, and the pre-initial proposals, that is the hydro, the TD, and the backtrack, right? So these are some of the elements that are being utilized by the low complexity multipath routing, which retains the carefully formed structure and then that constructed, right? So these are some of the newer versions of the protocols that are being utilized for self-learning networks, right? So I'm just quickly going through these things because they are much of a theoretical part rather than the discussion part. So you can just definitely read them, and I've just kept in the slides so that yeah, everything is there and you're able to see what advantages this IPv6 would hold for us, because this is one of the protocols that you'll just recently start using. I don't know how many of you are using it also, but right now I am not using it because the networks available to us are pretty much working effectively on IPv4 also. So header format specifies and the trade-offs are there. The routing security framework from the start or the limited tolerance, etc., are being these are most important details that we must always understand for these kind of protocols, right? So standard bodies in the transformation are in this form of ZigBee 802.15.4. We have RPL IPv6, we have 6 low WPAN, TCP UDP, many more to come, right? IETF core, we have IEEE 802.154 EG also, right? So there are so many protocols that are actually existent and which are also coming up. There are so many things that are coming up, and we will just be knowing them once a newer system comes into a picture. Say an Apple iPhone is utilizing almost thousands new protocols while the new iPhone is launched. So maybe we are not using them, right? Maybe we are not using all the things, but still that particular technology, that particular phone, mobile phone utilizes all these features. And because it is utilizing some features, it is one of the most secured phones available right now. Right? So everything is dependent on the type of protocol and the operating system that we are utilizing and we are putting into that machine, right? So machine functions accordingly. So opportunities and open problems, very interesting, right? What are they? We have to do quantitative analysis, design of WSNs in context layered of IPv6 architecture. The objective is objective function is the trade-offs, the utility, the table management algorithms, etc., right? So classic issues in the new concepts can definitely be introduced, like what? The transport layer protocol, the compression, the cross layer, or the optimization, right? Now we have done this with transistors, the piecewise linear analysis, right? Ideal set aside for lack of knowledge is the piecewise source routing. This is another thing that we can do. And let the chaos region and the rain in the chaos start. The killer app for WSNs. This is how you can see the world, right? So energy and environment impact of extraction, use, and disposal. The problem of the industrial age. We need to find the information age solutions to the industrial age problem, and fundamental transformation in the architecture of the electric grid, right? So how this is done? Have a look. Traditional load following grid. So grid, or this entire thing is producing the energy. Now what happens? Generation, transmission, distribution, and demand, right? So this is how it looks like. Very simple. We are generating the energy, transmitting it, then distributing it according to the demand that we have. Non-dispatchable sources, right? Aware of the interactive loads. We are communicating with each other. Now if we give it in the phones only, if we give it in the machines only, you will not require this kind of a structure, and you can directly communicate, right? Again, it depends. So that is why this low, LOW, becomes very important. Everything is inside the system. So the protocol also has to be a low power protocol. That is why I was trying to tell you the entire structure in that. So when we're talking about some low pan devices, the protocol structure has to be also utilizing the low power features, right? So I'll just move aware cooperative grid, right? We are aware the cooperative grid is aware about the load, etc. intelligently. So monitoring, model, and mitigating, that is the deep instrumentation, waste elimination, and efficient operation, right? This is what we require out of this particular grid. So forecasting, tracking the market availability, the pricing, and the planning is done. The macroscope in this case is, again, I'm utilizing that same figure over here where we observe complex interactions over the time and space, and then we analyze. So where to start? We have some buildings, we have some transportation industry, we have some electric energy, we have some renewable energy, right? So everything, how they are consuming the energy, right? So buildings is what they are. Where coal is used, where the prime, wherever the coal is used, the prime replacement would be the renewable power supplies, right? The other buildings, how they are utilizing the energy, how lighting is coming inside it, and how we can reduce the structure, right? So everything is dependent on this energy consumption. Now, why I am talking about, now have a look over this diagram, right? Energy transparent building. Have a look over this. We have a central vent, we have an office HVAC, we have an BOP HVAC. Again, this is all connected through some protocol structure which is connected to a server. Now it is actually helping the building to extract maximum amount of light when there is sun available, when the external light is there, right? So you're reducing the energy required by the building. Energy consumption is reduced, lighting is improved. Okay, plug loads go off. This is how the intelligent system comes into picture. So again, all those protocol structures that we have just discussed are coming into picture in this particular format also, right? So the next part is the uniform access to diverse physical information, where again we are talking about using of this S map, where we have physical information available and the applications, right? So physical information is what? Structural, weather, environment, actuator, the geographical conditions, the electrical and the water. Now they're mapped with the application part. Application part means the modeling, the control, the storage, the debugging, authentication, etc. Again, dependent on these aspects, right? So IP, again, I repeat, IP is everywhere. So real world, you see all, I have just tried to paste few things over here, and you see everything is connected with the internet. So if internet goes, everything goes down these days, right? So very important that the internet stays alive. And then once internet stays alive, the protocols are definitely being utilized at a particular point. This is just a normal diagram of a particular building. I got it from the same source that I was utilizing, right? So this is a Siemens auto demand response building where lights, plugs, servers, nano fabrications, and other devices are being controlled through different protocols, right? So this is a Siemens framework where they are utilizing the internet features and the protocols to control their sensors and actuators, and hence reducing their load, right? So if you see, this is how it is being done. Sensors giving the data to the controllers giving the information through the modem to the Apoge server, who is controlling the entire thing through internet, and all the buildings that are connected with the internet part in that particular area would receive that message. If they are having the facility, they can also control it accordingly, right? So that S map is given to a gateway, and then everything is done, right? So these are some of the real-time examples that we have for personalized automatic lighting control, and they are being utilized effectively. So We have a Python Django also being controlled, right? There are three controllable ballasts that need to be controlled in this. So 6,000 plus points in a modern building, 229 1 meters. There are different sensors, control outputs. So everything is monitored and controlled through different protocols. Again, so if we have this structure. Have a look over this structure. So energy conservation done through different protocols. Again, try and think what we were talking about and what we have come to. So local plus action webs combined together, they're helping us to analyze how Internet of everything can be actually embedded inside to reduce the power consumption. Also helping us in analysis of different devices, also enabling different other protocols to be utilized, which were just using everything. But here we're trying to utilize the features of the maximum features of the machine that are available, right? So these are all learning-based algorithms. Again, these are the different dynamic charts that have been taken through this building. So human building interference and that is reduced as far as any power plant, the nuclear plants. If you see all those things, they're very less in human interference. Everything is machine monitored, and again, if we connect them with the internet, the information that we gather out of those sensors can be utilized for other purposes also, right? So this is it as far as I'm concerned. So conclusion is that internet is everything and is here, right? It is definitely here. We're utilizing it. I am connected with you. All your 100 participants are connected with me, sitting in different areas. Again, we are connected through internet, and how we can communicate. We are already utilizing so many protocols. The Zoom system itself is utilizing so many protocols to transfer the information. The PowerPoint is going to you. The voice is coming to you, the video is coming to you. There are so many protocols working behind it, right? Right now we are still utilizing the features of IPv4, but once we go to IPv6, you'll see a drastic change in what we are doing right now. So 15 years of deep innovation and research, critical WSN breakthroughs, key IPv6 deployments, worldwide community of students, faculty, and industry coming into this, engagement of international organizations. Fundamentally, this is a new scientific instrument that can be actually utilized for betterment of all of us, right? So that's it. As far as I'm concerned, I just needed to give an overview of all the protocol structures and how they can be utilized. So this is it from my side. I would shift over my attention to the question and answers, though there was a lot of literature involved in this, right? So I hope that this literature would help you all understand how we have evolved from what where we started and where we are right now, right? So that's it from my side, sir. Thank you very much.
Thank you,
I'm
sir.
open to the questions now.
Sir, there
Sir,
is
there is
one
one
question.
question from participant. Sir, hello.
Yes, sir. Please tell me. It's very near to you, I think so, sir. So
Sir, will jobs
there is
are
an echo
available?
coming. So because there are two mics very near to you.
Yeah, sir, yes, sir.
Yeah.
Let me-
Please go ahead, sir. Tell me.
Yes, sir. Will jobs are available with this by the end of 2021?
Pardon?
Will jobs are available with this by the end of
I'm sorry, sir. Your voice was cracking.
tracking, sir?
The
Just
voice
a
was
minute.
cracking. I was unable to hear the question clearly. Yes.
Okay, just a minute, sir. Just a minute. Sir, am I audible now? Sir, am I audible now?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. You are audible, sir.
Yes, sir. The question is, will jobs are available with this by the end of 2021?
Okay. Okay.
Yes.
So look at the market scenario these days. Just given you a few examples, working examples of. Can I just stop sharing the screen, sir? I think I've already done that. So right now what I can do is I can switch on my webcam also. So it will be easier for me. Now, see, you have asked a particular question that where is the job scenario in this particular part, and the jobs are very see, there is a lot of job structure available as far as the protocol structures are concerned. Now, if you talk about the indigenous companies, Infosys, even IBM, they are looking forward for the scientists and the engineers which can develop certain low power protocols for their devices, right? So Wipro is leading in this. Wipro has developed so many products with low pan. When you search with low pan, you'll see Wipro with a lot of innovations being done. Even IBM, right? So IBM is developing a module. I was with one of the IBM officials, and they are developing a module where you do not need to talk to a designer who say you're going for a particular function and you're very confused in what you want to wear, right? So they are trying to develop a module. They've already done that, and you just tell the module a particular requirement, and it will tell you what you can wear for that particular function. So it can be very specific also. Again, everything is being worked on using the different protocol structures, right? So until and unless these protocol and intelligent algorithms come together, yeah, these companies will not be able to work. So they are working extensively, again I repeat, they are working extensively towards designing of new low power PAN networks, right? And once you try and develop these networks, you definitely require some protocol standards, right? Intel is working hugely on these on the development of protocols because they are coming up with so many processors these days. You see the processors with Wi-Fi capability, right? So Intel is leading in those processor configurations, and when they talk about processor configurations, they are referring to newer protocols being developed because they have already envisioned what type of technological changes would happen, and they want to stay alive in the market, right? So there are so many things, sir. If anybody even has written a paper on some protocol standards, I'm guaranteeing it that if a company, if it is cited somewhere in good journals, you will definitely get a call from somewhere. One of my PG scholars has already got it, right? So WSN sensor networks and then working with low power devices or low power protocols will fetch you a very good opportunity in India as well as abroad. I can guarantee you this, right? But you need to be very novel in nature. So differences between IPv4 and IPv6, right? This is what you want to ask, ma'am. I'll just switch over to chat.
Sir, yes, sir. Samiullah.
Right. I got that. IPv4 and IPv6, right? So see, these are two protocol versions. One is 32-bit and other one is 128-bit, right? So if you see the difference in the bit patterns, the addressing increases in IPv6. So once you increase the addressing, it is basically IPv6 is having an alphanumeric addressing method, and IPv4 is utilizing the address, the ARP or the address resolution protocol. So the 192 point that and point this, right? If you see those addresses are being utilized for the IPv4 part. IPv6 is completely different structure, and it is using NDP or Neighbor Discovery Protocol, right? So these are some of the basic ideas between the two. If you want to know further more differences, I can highlight that the addressing range, you will see, addressing range for IPv6 is a larger, quite large, and it can produce a heavy number of addresses, a large number of addresses for your machines, right? Address representation is in hexadecimal number. Other than that, IPv4 was again using decimal format, right? So hexadecimal is again is one that is understood better by the machines, right? IPv6, I can also call this as packet flow identification, right? So it is utilizing that packet flow identification, which was not available in the earlier protocol. There are different checksum fields also in that particular section, and encryption and authentication is also provided in IPv6, right? The problem is that all the things when they are combined together, I don't know whether you're able to see me or not. The IPv6 protocol is pretty advanced and recent protocol structure which can be utilized for all the machines, right? So in WSN, what is the role of cryptography, and can we use the WSN to reduce the social distancing during COVID? Yes. We can definitely reduce. Answer your first question. Thanks for asking this. What is the role of cryptography in WSN? It has a huge role, sir. It has a huge role. WSN and cryptography are two things that go hand in hand, right? I can call this as. Cryptography basically, if you see, when we're talking about some sensor networks, we're talking about cryptographic techniques for that, where we want to actually embed certain techniques of cryptography so that the data is preserved and it is not accessed by all the people or all the intruders. So cryptography is one of the most important aspects, as I can call, for the WSN networks, right? So there are so many research papers that you will find in the literature where they will talk about the cryptographic techniques being utilized, the asymmetric key encryptions, or the digital signatures, or the other things basically which are used for evaluating the cipher codes that you develop for the cryptographic achievements, right? And can we use WSN to reduce the social distancing during COVID? WSN can definitely be utilized for reducing the social distancing. If you, but again, a lot of sensors are required for that, sir. The part is that these sensors must be trained enough so that they actually understand that whom to detect and whom not to detect. So we need to put in some data that this person is COVID positive and this is not, right? So if we can transfer this information to the sensor networks, then definitely this can work as social distancing tool. But I am not that much sure that because there is no such technique available which can just see and identify that a person is COVID positive or not. So if we cannot do it, then it will be very difficult for the machine also to understand whether to ensure that social distancing with this person has to be maintained or not. Yes, if you are targeting all the people and assuming that everybody is having the disease and they should remain almost 2 feet from each other, then yes, WSN network would work perfectly in that condition, right? And even if you are able to if you are able to tell the machine that this particular area has these much sensitive patients, those who are moving around, then also it will be able to tell you that where to go and where not to go. There are so many things that you can do with it, right? So yes, definitely we can work with it, and you can develop your own protocol also for this. Definitely you can work over. Right, Shahnawasi, thank you very much for asking the questions.
One more question from participant.
Yes, sir.
How to
Yes, sir.
Yes, sir. Just a minute, sir. How to start writing new protocols?
How to start writing new protocols? See, now what you need to do is, I've just given you an overview of the protocol structures, right? So you need to first study the protocols that are actually existing. Say for that example, you want to develop a protocol for a Wi-Fi network. So you need to study the available protocols for a Wi-Fi structure which are being utilized. Once you have the data and the structure available in front of you, then you study, in that study only, you just find out what machines are available which can help you transfer the information and receive the information. So if you are knowing both these things, then you have to have a problem also that this protocol is not performing this kind of an action, right? Once you know that, and once you know the machine structure, it is very easy for you to design it. You can write it in C, you can write it in Python, you can write it in assembly language, right? Whatever you are comfortable with, you can write a code, and your machine would start behaving as it is, right? I will tell you a very simple thing, right? Say I haven't installed Zoom on my machine. I haven't installed that app. So that app is also what? It is a protocol structure for me. That my machine, once I install it and I click onto it and log into it, the Zoom features would be available, right? Now I haven't installed the app, but in the sense I'm using a shortcut. What I'm doing is I am accessing the Zoom app through my browser, right? So to utilize those features, again, my browser had to be some protocol enabled. Right. So again, see, there are so many things that you can do. Now you can build your own browser for that, which accesses all the apps, or which helps you that say if your machine is unable to install any of the newer versions of .NET or whatever you can say, if you install this kind of a thing, your machine becomes friendly enough to install everything, right? So that can be another thing. So you need to work out what is the problem, where the problem lies. Once you identify that problem, the algorithm can definitely be written. And there are so many numerous problems available around, right? Okay, Rajeshwari ji, thank you very much. Thanks a lot for asking. I don't know, my network is too slow right now. So I still hope that you are able.
Sir, one more question is there, sir. Hello, sir. Sir, can you able to hear me? I cannot able to hear. Can you?
Okay.
Sir is not. Sir? Yes, sir. Actually, you can see one more question is also there. I got this one.
I'm sorry, I think I got disconnected. So I don't know whether the answer to the question I was able to give it or not. Are you able to hear me now?
Yes, sir. We can able to hear you, sir.
Right. You were asking something. This is what I
Yes,
heard.
sir. One more question was there from the
Yes, please,
participant
ma'am.
side. From
Please.
where we can get the data set of social medias?
Data set of social media. There are so many websites right now available. If you can actually go to a MATLAB server, you will find a huge amount of data there, right? So what I can do is I can in the presentation I'll when I'll post you, ma'am, I'll write all the names, right?
Yes, sir.
Where the data sets are actually available, and where you can actually get this information. I will definitely name a few, but the point is what kind of data we require, we need to search accordingly, right? So data sets are they are very important, but with whatever data is freely available, you'll see a COVID data freely available these days, right? So whichever country is doing whatever thing, they are supplying this information free of cost for the AI developers to develop certain algorithms which may help the countries to tackle this situation, right? So that is why this data is freely available right now. I don't know the exact platform right now, but I'll definitely write down in my PPT after this.
Yeah, even one of the participants also written like
IEEE data sets.
IEEE data set. Yes, sir.
Yes, yes, yes. There are so many, sir. There is one with MATLAB also. MATLAB is also providing this kind of a feature service, and even real-time data can be put onto that cloud. So there are different clouds basically which are coming into picture, and they are helping to analyze the things. Right. So if you write MATLAB cloud services, right, or cloud center, I think you will get different things where you can create your own account and access the cloud center also, right? Kaggle also there, but the data is not available there. Kaggle, I am not sure, sir. Shahnawazi, I'm not sure about Kaggle. I haven't used that. But yes, I can definitely guarantee you this that there is right now available. Right, ThinkSpeak is one of them. So I'll just I don't know whether you are able to see the screen or not, but this is one of the services. ThinkSpeak, right?
Sir,
So
we cannot
this is
able.
one cloud service that is available. I know that there is some problem in the network right now. But I've written that in the chat section. ThinkSpeak is what you can use, right? The service provided by MATLAB only. Are you able to hear me?
Yes, sir. Yes, sir.
Yes, 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 yes. So ThinkSpeak is one of them, and there are many more cloud services which if you have any data set related to cloud security, yes, I will definitely share it, Shanwazi. Cloud security data sets are fine. The only problem is they are paid, right? So the point is that if you require certain kind of informations which is not in public domain, it will be very difficult for you to get that. They are all paid data domains, and they charge something for the data that they provide, right? So, but still, I'll see if there are any available for free services, right? So I'll definitely try and see that. Yeah, you're most welcome. You can mail me that, no problem. So again, I'll show you the mail. I can write the mail IDs over here in the chat box itself, so that everybody is able to get my number and the contact number, right? So I've already mentioned it. So yes, that's it from my side. Ma'am, anything else?
No, sir. Thank you, sir. Thank you for the wonderful session, actually. As you
Right,
said,
great.
after the lunch also, we will not feel bored, really. Though I'm not from
I
the
was
computer science background, but really it was like understandable and it was so exciting. First time I heard from you, and so it's nice to hear from you, actually. It's great, great
great.
session.
Thank you. Thank you very much. And I was really worried about after we have lunch, and it's very difficult for all of us to stay alive in the class, right? and that too, it is very difficult talking to the screen. So I hope I was able to ignite something in all of the participants, and if few of them also start working, it will be a great thing, right? So it
So
is a
it was
very
so excited, sir. Session was so wonderful actually. Though I'm saying you,
great.
sir, I'm not from the computer science background, but still I understood. So definitely
Oh,
participants,
great.
definitely they understood.
Great. That's really lovely to hear from your side. Thank you very much, and a big thanks to everyone who has stayed alive and uh, listened to this difficult session of mine. Thank you very much for having me again, ma'am.
Thank you, sir. Thank you so much.
Thanks a lot. Thanks a lot. I'll definitely share these PowerPoints with you, right?
Yes, sir. Yes, sir.
Yeah. Thank you very much. Thank you.
Thank
Thank
you,
you,
sir.
Binduji. Thank you very much.
Thank you,
Thank you,
sir.
sir.
Thank you, sir. Thank you for the GITM entire college, and thanks to all your team members. Thanks to the coordinator Kamal Nathan sir for actually linking with me and then rescheduling my talk. I'm very grateful to him. This talk was to held on 17th, and he helped me change it today. So thank you very much, Kamal Nathan ji, for actually helping me out. I'm very
Thank you,
Thank
sir.
you, sir.
thankful to you.
Thanks for
Thanks for
your
your
valuable
valuable
session.
Welcome,
session,
sir.
sir.
Welcome.
Thank you, sir.
Welcome.
Thanks a lot. Thanks a lot. Thank you, everyone, and hope that you had a nice session. Thanks a lot.
Yes, sir. Thank you, sir, for the information. Thank you, sir. Okay, participants, thank you for your cooperation. Again, tomorrow we will meet. Now I'm going to end the meeting. Thank you all. Already I posted. I hope everyone fills the attendance form, because that is also compulsory and that is also the important information. I hope everyone fills the attendance form. If you have not filled, then kindly fill it. Uh, it will be required for the attendance purpose. For yesterday's session and today's session, all the materials we will upload soon. By evening, we will upload. Okay, now I am going to end the meeting. Thank you all.